Which of the following statements accurately describes kernel ridge regression? It utilizes a linear kernel to map data into a higher dimensional space, allowing for nonlinear relationships. It's a regularization technique that adds a penalty term to the loss function, preventing overfitting. It uses a kernel function to implicitly map data to a higher dimensional space, allowing for nonlinear decision boundaries. All of the above. It utilizes a linear kernel to map data into a higher dimensional space, allowing for nonlinear relationships. Incorrect. Kernel ridge regression uses a nonlinear kernel, not a linear kernel, to transform data into a higher dimensional space. This transformation is the key to capturing nonlinear relationships. It uses a kernel function to implicitly map data to a higher dimensional space, allowing for nonlinear decision boundaries. It's a regularization technique that adds a penalty term to the loss function, preventing overfitting. Correct. Kernel ridge regression incorporates regularization by adding a penalty term based on the squared magnitude of the coefficients to the loss function. This prevents overfitting by controlling the complexity of the model and improving its generalization ability. It's a regularization technique that adds a penalty term to the loss function, preventing overfitting. It uses a kernel function to implicitly map data to a higher dimensional space, allowing for nonlinear decision boundaries. Correct. Kernel ridge regression leverages a kernel function to project data into a higher dimensional space, without explicitly performing the transformation. This allows for nonlinear decision boundaries, enabling the model to capture intricate relationships that linear models might miss. It uses a kernel function to implicitly map data to a higher dimensional space, allowing for nonlinear decision boundaries. All of the above. Correct. All the statements are accurate descriptions of kernel ridge regression. It uses a kernel function, often nonlinear, to implicitly map data to a higher dimensional space, which allows for nonlinear relationships. This technique is enhanced by regularization, which adds a penalty term to the loss function to prevent overfitting. These features combine to make kernel ridge regression a potent tool for various data analysis tasks. Kernel ridge regression combines the power of kernel methods, which allow for nonlinear relationships by mapping data into a higher dimensional space, with the regularization capabilities of ridge regression, preventing overfitting. All of the above. Kernel functions are mathematical operations that calculate the similarity between data points in the transformed space. They are crucial for capturing nonlinear patterns. Linear, polynomial, radial basis function (RBF), sigmoid. In image recognition, kernels help identify patterns like edges, corners, and textures within images, which linear models might struggle to capture. Regularization is a technique used to prevent overfitting by adding a penalty term to the loss function. This penalty discourages complex models that might fit the training data too closely. In time series forecasting, regularization is used to make predictions more robust to noisy or erratic data points. Ridge regression is a linear regression technique that adds a penalty term based on the square of the magnitude of the coefficients. This penalty shrinks the coefficients towards zero, reducing model complexity and preventing overfitting. In natural language processing, ridge regression can be used to predict sentiment scores for text data, where the regularization helps prevent overfitting to specific words or phrases. Time series forecasting, nonlinear regression, image recognition, natural language processing. Let's say we have a dataset with two features x1, x2 and a target variable y. We want to model the relationship between these features and the target using kernelridge regression. Suppose we choose a polynomial kernel of degree 2. This means that the model will implicitly map the data into a higher dimensional space, including terms like x12, x22, and x1 by 2. The regularization parameter alpha in kernelridge regression controls the trade-off between fitting the training data well and preventing overfitting. A higher alpha value will penalize complex models more, leading to simpler models with better generalization performance. The choice of kernel function in this case. The polynomial kernel determines how the data is transformed into a higher dimensional space. And this choice impacts the ability of the model to capture nonlinear relationships. From sklearn, kernelridge import kernelridge. Model kernelridge alpha 0.1, kernel RBF. Model, fit X-train, Y-train. YPRED model, predict X-test. In this code, alpha controls the regularization strength, and kernel specifies the type of kernel to use here. The radial basis function. The model is trained on the training data using fit, and predictions are made on the test data using predict.